Hey everyone, I'm going to finish our 15.2 notes. I hope you don't mind that I have it already written out and then I'm going to talk about what you see. I think the notes will be much shorter that way rather than you guys waiting on me to write everything out. In this particular problem, you have a SUV that you want to sell in Kyrgyzstan, I believe you would say that. And your SUV has a mean value here and a standard deviation value. And you're interested in selling it, and they are actually going for about that much in Kyrgyzstan. And it has a standard deviation of that much. Now, I believe that's called SOM, but I could be wrong there. It's an interesting little problem here. And we want to buy a scooter. Oh, and that's the scooter. That's how much they're going for. And every US dollar is worth that much. So we have like a conversion, which would be a multiplier. And so I want to sell my SUV that's in US dollars, and I want to buy a scooter. And the question here is about profit. So I would need to convert the price of my SUV to SOMs, and then I'm going to subtract what what the scooter cost me, and see what I profit. So we have defined some variables here. We said let A equal the sale price of the scooter, let B equal the sale price of the SUV, let B equal the actual price of the scooter, and let D equal our profit. And so I came up with this little handy dandy equation right here that is going to convert our SUV into SOM right here. And then I'm going to buy my scooter there, subtract it, and then I will get my answer. Yeah, the first thing we have to ask ourselves, is our situation independent? And I believe that the cost of the scooter and the price of our SUV are independent of each other. One does not affect the other. So because we're working with independent variables, we can go ahead and jump right into our expected value formula, which tells us that we can multiply by the multiplier, which is what I'm doing here, and then we can subtract off that price of that scooter. And so I substitute in the average selling price of the SUV. I subtract off the average selling price of the scooter, and I end up with my answer here, which I believe was a 2, and something got erased there. So there we go. 202,190 SOM. Now variance is a little different. The subtraction gets turned to addition right there. So do remember that we cannot subtract variances, we have to add. We have a multiplier of 38.5, but anytime we have a multiplier, we square our multiplier. And our variances are added to each other, but they only gave us standard deviation, so I must take my standard deviation and square it. That way I actually have a variance. My multiplier here turned into this number, and I'm going to calculate a grand total for my variance, take the square root of it, and voila, I have my answer. All right, last problem, and I have a lot written here, but it's kind of going to fly because a lot of the stuff is redundant. We are packing stereos, and then we're going to ship the stereos. So we pack them up, and then we box them, and then out they go. To pack has a mean of 9 minutes and a standard deviation of 1.5 minutes. And to box them up, we have a mean of 6 minutes and a standard deviation of 1 minute. And notice this word right here, that we believe the boxing stage and right up here the packing stage can be modeled by a normal distribution. So that's going to help us when they throw out this word probability here. And here, what percentage? That implies to us that if they say normal and then they say probability, that we're going to go to that curve, we're going to find a z-score, and so we're going to find an answer that way. So what is the probability that packing 2 consecutive systems takes over 20 minutes? So 2 consecutive systems, and we're only packing. So that means I'm going to, if you look down here, just add 9 plus 9. Okay? Then I'm going to add my variances to each other as well. And when I add my variances to each other, I have to square my standard deviations to get the variances. So 1.5 squared plus 1.5 squared gives us 4.5. And in order to get that standard deviation, we take the square root. Okay? Now remember, the original question is asking for the probability that it takes over 20 minutes. So my key number here is 20. So I place my 20 here, minus my mean, which was 18, divided by my standard deviation, which was 2.12. So keep in mind here, you had to find the average, you had to find the standard deviation, and then you have to substitute in the value that they give you. This gives us a z-score of 0.94. So the probability that the packing time of two consecutive systems is greater than 20 minutes is the probability that you have a z-score greater than 0.94. It turns out to be 0.1736. We can go to the table, and since it says greater than, we can subtract whatever probability it gives us away from 1 to get our answer. Or we can, if you guys recall, I believe it's second VAERS. I don't have a calculator for me right now, but second VAERS option 2, create a lower bound, which is 0.94, create an upper bound, which I said if it goes to infinity to type in 99, and that should also give you this answer right here. So that's the probability that packing two consecutive systems takes over 20 minutes. The next question says, what percentage of the stereo systems take longer to pack than to box? So we want my P minus my B right here. Packing minus boxing. We need that difference to be greater than 0. If that distance is greater than 0, then P's taking longer than B is. Once B is taking longer than P, when I subtract the two, I would not be greater than 0. One would surpass the other. I would subtract off too much, and I would be negative. So as long as it's greater than 0, we know that we are taking longer to pack than to box. And if I want to find the expected value here, I simply subtract. And so that takes me an average of 9 minutes to package. It takes me an average of 6 minutes to box. 9 minus 6 gives me an average of 3 minutes. Remember, variance, if it wants you to subtract, you need to add the two variances to each other. But we do not know the variances, we know the standard deviations. When I square the standard deviations, I get the variance, so 1.5 squared and 1 squared, and I get 3.25, but then I must take the square root of that, and it gives me 1.8. So now that I have a mean, and now that I have a standard deviation, I can find a z-score. I find my z-score by, remember, I want my probability to be greater than 0, so the key number here is 0. So there's my 0, there's the mean I found, and there's the standard deviation I found. Then the z-score I get is negative 1.67. So the probability that my D is greater than 0 is the same thing as the probability of my z-score being greater than or equal to negative 1.67. This actually turns out to be 0.9525. Since it says greater than, we could find that percentage and then subtract it from 1. Or we can create our lower bound, our upper bound, and hit enter, and we should get the same answer as well. I know I talked fast. I know I just went through that in a hurry. You can find all these examples in your book. I believe this one is around page 402. All right, so if you want to take another look at it, and they draw the curves for you and everything. One other thing I would point out is that I went through the what can go wrong part of the chapter, which is typically always toward the end, and I really like that because it's all those assumptions that you have that they want to debunk, and it is on page 405. I really, really encourage you guys to read What Can Go Wrong on page 405. I thought it was really helpful for myself. All right, I hope you guys are good to go. I'm so sorry I'm missing. If you have any questions, just email me. Thanks, guys.